Hey guys! So this is a shortened version of our Arithmetic Sequences series lesson that we're given here for e-learning. We're going to cover the basics here of arithmetic series today because we already covered arithmetic sequences last week. And you will want a calculator with you as we go through this. And I'm going to try to keep this video as short as possible to ease your e-learning time needs. Alright, so we're going to be talking first about something called arithmetic means. We're going to find how to calculate an arithmetic series. We'll talk about that in a minute. And then maybe an application problem or two at the end. So, first thing, last week we worked all sorts of problems involving arithmetic sequences. So arithmetic, remember, were the sequences where you went up or down by integral steps. Not always integers, but you added 3 each time, you subtracted 5 each time. So that was an arithmetic sequence. First topic of today is to talk about what's called an arithmetic mean. And an arithmetic mean kind of has to do with how many hops it takes you to get from, this place to this place in the sequence itself. So that formula should be looking familiar to you for arithmetic sequence. But this is what arithmetic means mean. So if I look between 7 and 47 within this arithmetic sequence, there are 1, 2, 3 arithmetic means in the middle of it. Now, this is where it gets a little confusing. Sorry, I had to turn off my sounds. Okay, so arithmetic means are how many blank spaces were in between those two values. As far as hops go, to get from a 7 to a 47 in this particular sequence, you added, and it looks like we're adding 10, not 1, not 2, not 3, but 4 times. So the amount of hops to go from place to place isn't the same as the number of arithmetic means between two numbers. So for me, whenever I do these questions, I really have to map it out like you see on this example. So write an arithmetic sequence that has 3 arithmetic means between 3.2 and 4.4. Okay. So we start here and we end here. And I think about this common difference that I'm adding every time. So I added it not once, not twice, not 3 times. You had to add it a 4th time to get to 4.4. So what I'm going to do is I'm going to write up a little algebra. I'm going to say you start with 3.2, and then we added this common difference 4 times, and we landed at 4.4. My algebra is a little rusty, but I'm going to give it a go. All right, I'm going to subtract 3.2. So the common difference after I divide by 4 is 0.3. Now, that's wonderful. I'm going to just double check that I didn't do something incredibly stupid, because that sounds like me. So if I add 0.3, this would be at what, a 3.5, this would be at a 3.8, this would be at a 4.1, and then lo and behold, I add 1 more and I get to 4.4. Now notice the instructions said write an arithmetic sequence. We're not done. I actually need the arithmetic sequence. So remember the formula for arithmetic sequence from last week. This is the version that I was really happy with if you just stopped here. And that's what I'm going to do. So our first number in the sequence was 3.2. We just found the common difference to be 0.3. And then to keep the sequence in general notation, you just leave it as in term of the nth term. There's your sequence. Do not simplify that. No one has time for that business. All right, so here's another example from your notes. Write an arithmetic sequence that has 3 means between 17 and 39. So here's 17. There's 3 blanks, but be careful, that's not the same number as hops. So to get to 17, from 17 to 39, I think I said that backwards, whatever. You add 1, you add 2, you add 3, and you're going to have to add 4 more. It's a coincidence that this problem also had 4 common differences. So 17 plus 4 of these common differences got you to 39. And then we solve. I don't know why, guys, but my general arithmetic, which is never really that great, is really bad. So if I make a mistake, I'm sure you'll let me know. So if I divide both sides by 4, you get a common difference of 7. Yeah? No, something's wrong. Oh my gosh. Do you think I cursed myself when I said that? Because that's 22. Okay, so that's 5.5. Like I said, the difference is 5.5. So again, I could double check that I did this right by going back into the formula and adding 5.5 each time. So what, 22.5? I don't think I should be doing this on my own. All right, 22.5, and then that'd be 28, and then 33.5. I hope that's right. I'm not really feeling very confident anymore, guys. It does say write the arithmetic sequence, though, so I should come back and actually write the arithmetic sequence. So my first term being a 17. Your common difference, I just realized, was adding 5.5. And then multiplying it by the quantity n minus 1, leaving this in general form. And that, my friends, is your arithmetic sequence. So really a topic from last week, but a new vocab idea about arithmetic means. This one's very similar. I'm just going to skip it for the sake of time. Plus, I'm feeling a little down because I got that one wrong almost. Okay, so here, this is new. So we're going to take this arithmetic sequence, and we're going to say that's not good enough to list them out. I want you to add all the numbers together. So we are going to teach you a couple different ways here for PreCalc, and one of them is going to be straight up on your calculator in a minute, which I think you'll like. This is the formula we use the most often. So very famous formula in math, actually. So the number of terms divided by 2 times the sum of the first number plus the last number. So that's really handy, but what if you don't know the last number? Well, then you can use this version of it, or you can just go find the last number using your knowledge of the arithmetic sequence. I'll show you what I mean in a second. I actually never remember this formula, and it's not bad. It's basically just someone took the arithmetic sequence formula and plugged it into the existing formula up here, and then simplified it. But like, I only have so much space in my head for formulas, and this one didn't make the cut. So I don't ever use this formula. If you want to write it down and use it, you go right ahead. Let's talk about what this looks like, though. And then I'm going to show you a calculator fun in a moment. So you'll notice they use S to represent the sum of any sort of a sequence. It's called a series in math. There's a lot of notational things that are going to come up here, so be careful. Let's jump into an example here. Find the sum of the first 50 terms. So if instead of like listing out all 50 terms, I gave you like a little snapshot of them. Starts at 11 and then blah, 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 and it ends at 158. So using this formula, which is S sub n equals n over 2, and then times the quantity of your first term plus your last term. So for us, 50 is going, the number 50, excuse me, 50th term is our last term. So what we're going to do here is that goes in for n. And then the first term is obvious, right? It's the 11 right here. And then a sub n is representing the last term or the 50th term for us, which, if I can like look, it's 158. So it's all set up. It's ready to go. I could crank that in the home screen of my calculator, and I'm going to cheat because I already did this. And I get 4,225. That's a great problem. Right? Neat little formula. You get to use it. Have that handy whenever you're doing any practice for us this week. Let's take a look at the next question and why this one's a little different. So this time I want you to add up the first 23 terms. Not crazy, right? We could do that. The problem is there's got to be a quicker way, right? So remember how there's two formulas for sum, and I said I wasn't really going to use the second one because I just can't ever remember it? This is what I'm talking about. They don't tell me the 23rd term. But I could figure it out because I noticed that this question has an arithmetic look to it, right? You're having a common difference of, okay, Bruzo, don't fail me now. Is that 11, right? Negative 11. So the common difference is you're subtracting 11 each time. Sorry, I had to go help with first grade homework. Okay, so where were we? We had our common difference of negative 11. Clearly I can see the first term, right? So the formula for the arithmetic sequence for this particular arithmetic sequence starts at 173, and then you wouldn't say adds negative 11, you just say like minus 11 times n minus 1. So if I'm looking for the 23rd term, I'm going to use that same formula, but I'm going to calculate it for the 23rd term. So that's where that 22 hops comes in, you know? So that gets typed in my calculator, because I'm not doing mental math today, and you get negative 69. So the 23rd term of this particular sequence is negative 69. I didn't have to like go and list it out and calculate it. Now what we can do is we can find the sum of those 23 terms by using this new formula that we have. So n over 2 would be 23 over 2, which already makes me kind of unhappy because that's gross, but I'm going to use my calculator. And then, remember, it's first term plus last term. It doesn't really matter the order that you do that in, though. Okay, so here's my first term. And then our last term we just found, right? This guy. So I'd crank that in my calculator. Voila. And I got an answer of 1,196. All right, I'm going to show you another way to do this question. And I'll be honest, this next way is my favorite way to do this question. We're going to use what's called the sum of the sequence on the calculator. So it's going to kind of be on the calculator, and you got to take notes at the same time. So what I would suggest you do is you write down this little formula here, and it looks like this. You go sum, parentheses, sequence, and abbreviates, of course. You'll do formula. Apparently I can't write today. And then you'll do your variable. Talk about what all these mean in a moment. And then first, comma, last. There's a little more to this formula. Once we get to the pasting menu, I'll show you what I mean. Those of you who are on an older calculator, you're going to have to like remember this order of how to type things in. On the newer calculators, it's going to prompt you. The other thing I suggest you write down are some notes of where we find these things. So sum is found, and I always forget this one, so let me look. It's second stat, I believe. Yep. All right. So I'm going to write a note here. Second stat. And then you have to go over to math. And then you're going to choose number 5. That's where sum is located. And then sequence actually is in a very similar spot. It's at second stat again. And then you're going to go over to ops, operations. And then this time you also choose number 5 to find sequence. Okay, so let me show you what that looks like on the calculator. And if you have your calculator, please play along. So. All right, so we go to second stat, the list menu. And I go over to math. I backed up, but you can go forward, of course. And you're going to choose number 5, sum. Now, while you're in that command, whoops, don't do that. While you're in that command, go back to that same menu, and this time pull up ops number 5, which is sequence. Okay, so this is the prompting menu that shows up on the newer calculators. EXPR stands for expression, so it's the formula. Remember, we kind of already had the formula because we found the 23rd term. I kind of forgot what it was, but wasn't the initial term 173? So what I'm going to do here is I'm going to write the general explicit formula. So 173, you can even say plus negative 11, like a weirdo, or you can just say minus 11. And then parenthesis, use your variable key here, and since I'm in function mode, it's just using x as a variable. If you're still in parametric mode, for some reason, get out of it and just go back to normal function mode, please. So there's the explicit formula. When it says variable, you just tell it what variable you're using. So if you're like a normal person, you're just using the variable key, so x in this mode. And then start and end. So they wanted us to start at the first term and go all the way out to the 23rd term. Now notice, I never actually told them what any of those terms were besides in the explicit formula. And then we're going to leave step empty, don't worry about that, and we're going to paste it. This is it plugging it right into the formula. Our older calculator friends, you're going to have to type that in that order, so write that down, and then hit enter. Oh, looky there, it's the same answer. Okay, so I love sum of the sequence. It is my absolute favorite way to do these questions. I find myself summing the sequence on almost all of my homework problems. So it's up to you guys how you want to approach these questions. Oh, back up. All right, let's do a few more together. And I'm going to try to mix it up a little bit. Maybe I'll do both methods on each question and you can see, make a decision for yourself which one you like better. So find the 82nd partial sum of this arithmetic series. So they didn't tell me the 82nd number. And unless I wanted to list them all out, like I'm not going to find it easily unless I use a formula. So since I noticed with both of these methods, I have to use the formula anyways, let's just go ahead and figure it out. So the sequence formula, the one from last week, starts off with a first term of -1. And then we have a common difference here. Looks like we are subtracting 3. So instead of saying plus -3, I'm just going to say -3. Hey, Loke. Did you get your homework done yet? No. Happens.
Print.
Gotta print it. No, we gotta submit it. Did you finish it?
Yeah.
Okay, gotta turn it in. Remember how to turn it in?
No, not yet.
Okay, I'll come see you in a minute. All right, let me finish this up. Just gonna stay here and watch?
Yeah.
Okay, cool. All right.
Squirrel.
Squirrel. All right, so if we go ahead and use this formula to find the 82nd term, that would look like this. I'd say -1 -3, and then 82 minus 1 is what goes in that parenthesis now. So 81 hops, if you want to think of it that way. I don't even know if I did it this way. Let's find out. What, baby?
It's like 82 minus 1 together was 82.
That's true.
20.
Yeah, this is some crazy math. I don't even think you want to think about this one yet. Okay, now notice, pre-calc, this is not our answer. That was just the 82nd term. So if you're using the sum formula for the first 82 terms, that's that new formula that we have. So 82 over 2. Scared him off. And then our first term, he's fine, plus our last term. Oh gosh, you ever record a video and you're like, this is bad. Yeah, this is bad. Okay, so the sum of these first 82 terms, I don't know, -10,045 is what my key says. I hope that's right. Now, I'm going to do that same question using sum of the sequence. So, remember, your newer calculators are going to prompt you, so you won't have to remember this, but for our notes, I'm going to write down what I'm typing in here. And I'm going to start with the explicit formula, which is this guy. You don't even have to, like, simplify it. So it's -1 minus 3, parenthesis, and then in function notation in my calculator, function mode, I should say, it uses x. Okay, and then I put a comma. On the older calculators, on the newer ones, I don't have to do this. I use my variable key, so I type x, and then we started at 1, and we ended at 82, because they wanted us to add up the first 82 terms. Okay, so again, this is what I'm going to be typing into my calculator. I just wanted to get that down for my notes. If you're really crafty, you can just pull up your previous entry and edit them. I find I'm pretty bad at that, like I screw it up. So here we go, second stat. Go over to math and choose number 5 to pull up sum. And then while you're in that command, go back there, second stat, go over to ops to pull up 5 for sequence. And then it gives you all this business, right? So we have -1. I already forgot. Hi, child. It was a common difference of subtract 3, right? So subtract 3. X minus 1 in the parentheses. No, I can't pause it. I'm on a roll. You're going to ruin my mojo here. Anything for you, pre-calc. All right, we're ending at the 82nd term. Hey, look at that. -10,045. All right. So regardless of how you want to do these questions, guys, it's your choice. All right, I got to go yell at kids for a minute. I'll be right back. Okay, back. This e-learning is fun. All right, here we go. Sum of the first 25 terms. Again, sum of the sequence on the calculator formula. Now, because I do have the first and last term, I think this one might be a good candidate for just using that sum formula that we were given. So remember, the sum formula would be the number of terms cut in half, and then times the sum of your first term and your last term. So what do we have here? So the first 25 terms would be 25 over 2. And then our first term was 7, and our last term was 79. And that is clearly not something I can do in my head, so I'm not going to bother. This is 1075. I think we've proven today that my mental math skills are weak. Okay, this should be kind of a newer topic for everybody. This guy right here, this is called a sigma. It is a capital Greek letter sigma. It looks like a big capital weird E. That's exactly what it is. Most newer notation books... Ooh, that's not at all. No. Okay, let me try this again. What they'll do is they'll put this part of the sigma notation underneath, is what I've usually seen, and then the top of it goes up on top. So what this is saying, that symbol means to add up all the terms. So it's saying starting at your 3rd term and going to your 15th term, add up a string of terms like that. That's what the capital sigma stands for. To sum, it's a series. So, I'm going to be using my sum of the sequence on my calculator because I love it, all right? So I'm going to pull up that same sum sequence. And again, remember the newer calculators are going to prompt you for this part. When it says the explicit formula or the expression, that's this guy. So I'm going to type 3. I'm going to use x because of the mode I'm in my calculator. I just use the variable key. 3x plus 1, comma. And then remember, since my mode is in function mode, I'm using x. And then this is weird. They're starting at the 3rd term and they're going to the 15th term. I don't really know what those terms are, and I don't really care because my calculator is going to do all my work for me. So when I crank that in the calculator, what I got 364. And these are fantastic questions when they're set up like that, because if they go ahead and give you the formula, yeah, I think I'm going to make the calculator do all the work in those cases. All right, so this is an application, and probably one that you can appreciate, you know, work, salary. These are things we need to know about. So an employee has a salary of $34,500. Each year thereafter, her annual salary increases by $750. So this has like vague, you know, memory from Algebra 2 questions about like, oh, her salary is going up, you know, a linear amount every year. This is an example of an arithmetic sequence. What will her salary be during the 10th year of work? Well, so if I think about my sequence formula, the first part, right, the first starting pay is this guy, $34,500. The common difference is what it's increasing by, so that's $750. And then sometimes we get kind of caught up with the, what does N represent? Does N represent how many years she's been working? Is it how many raises she's gotten? So we're going to let N represent the number of years that she's been working. So in her 10th year, we're going to plug in a 10 for N, but look at that formula. It says 10 minus 1. So that really is going to come out to a 9, but that makes a lot of sense because when she starts her job, it's like kind of like year 0. So like she's making $34,500. So after 9 raises is when she'll be making her 10th year's salary. So it's working out. At first I got nervous like I was going to explain this wrong, but we're good. So in her 10th year of work, she started off with $34,500. That's a 5. And then she had a raise of $750. And then she accrued 10 minus 1 raises. So she accrued 9 raises. So again, there's no mental math happening here in Abruzzo-land. When you crank that in the calculator, in her 10th year, she's making $41,250. It's not real great, actually, for 10 years. So what will her total earnings be after 25 years? So in this case, it's up to you. You know, sum of the sequence, or do you want to go find her 25th year of work's pay? You know, I love my calculator. I'm going to use sum of the sequence. If you choose not to use sum of the sequence, if you use that S sub n equals n over 2 formula, you have to go figure out what she's making in her 25th year. So I'm not going to do that. All right, her formula, remember, was $34,500 plus $750 times x minus 1. Of course, we use the variable x in this mode. the first 25 years of work. So that would be year 1 to year 25. And then this is always fun to calculate. How much money did she make in 25 years of working? Well, seems like a lot, but remember, it's over the course of 25 years. So she made $1,087,500. Impressive, I know. All right. So I think that's the end of our lesson. What Mrs. Hoffbauer has put together for you is a very short assignment. It's called 10.2 Practice. Again, it's up to you. Some of the sequence is really nice and works well. This newer formula works well too. And frankly, this is all kind of new to you. If you're still struggling on arithmetic sequences, you might want to go back and revisit that first lesson from last week on arithmetic sequences. All right, good luck, everybody.